Good day, learners. You're welcome to my channel once again. And today we shall be looking at Surds rationalization. I'll be introducing you into a concept called the conjugate of a surd. Now, in the process of Surds rationalization, what you are trying to do is to remove an irrational number from the denominator of a given question. For example, if I am given 2 over root 3 and I'm asked to simplify this. Now if you look at this is, remember that this is my numerator. If you remember your fraction, this is called your numerator and this is called your denominator. It is not right that your denominator has an irrational number. So I'm going to look for a process of removing this denominator as an irrational number and take it to the numerator, so that I'll be having a rational number in my denominator. How do I do that? Solution. To simplify 2 over root 3. Now, to change my root 3 to a rational number, all I need to do is to square here because it is root. It is square root. So if I square it, the square root, we cancel the square. So all I need to do is just multiply by root 3 over root 3. Now please take note of this. Root 3 over root 3, usually in mathematics it can still cancel out, which will give you 1. So I am back to this. But the essence of doing this is so that this, if I multiply this and this, the square will cancel each other, because this becomes root 3 squared. Now look at it, root 3 squared. This square, we cancel the square root. That is the essence of this. So let's repeat this process so that it will be clear. We are given 2 over root 3. All I need to do is just multiply both sides, both numerator and denominator, by root 3. So I'll just multiply here by root 3 over root 3. So that I'll be having 2 times root 3 will give me 2 root 3 all over. Root 3 times root 3 will give me what? 3, because it is root 3 squared. The square cancels the square root. So I've succeeded in removing the irrational number from the denominator and I've taken it up to the numerator. So it is okay now. You can have your rational number as your denominator. Let's take another example. Example 2. Simplify 5 over root 5. Now this is also very simple, like what we did before. All I need to do is what? Five over root 5. If I multiply both my numerator and denominator, root 5 over root 5. Remember that all I've done is just introduce a multiplicand of 1, because root 5 over root 5 is 1. So I've actually not changed my question. All I needed to do was just to eliminate this from the denominator. Root 5 over root 5 is still 1. So all this is what you'll be getting. 5 times root 5 is what? 5 root 5 all over. Root 5 times root 5 is root 5 squared. And root 5 squared will give me what? 5. Remember this process. Root 5 times root 5 is the same as root 5 raised to the power of 2. So that this 2 will cancel the square root. I'll be left with what? 5, which is what I have here. I can simplify this further. 5 here, 5 here, they will cancel out. So my answer will just be what? Root 5. So we've simplified 5 over root 5 to arrive at what? Just root 5. I hope this is clear enough. Alright. Take another example. Example 3. Say simplify 10 over root 2. All I need to do is what? Remember that the essence of rationalization is you don't want an irrational number at your denominator. I'm giving 10 over root 2. Because this is an irrational number, I will need to multiply both sides of my fraction, that's the numerator and denominator, by what is in my denominator, which is root 2. So I'll be multiplying by root 2, anything I do to the top, I must do to the bottom. Root 2 over root 2. Root 2 over root 2 can cancel to give you 1. So I've actually not done much to my equation. I only simplified it for my own choice. Now, 10 times root 2 is what? 10 root 2. Denominator times denominator, root 2 times root 2 is what? 2, because the square root will go out. Now, I can simplify this further. 10 over 2. How many times can 2 go into 10 is what? 5. Then I have my root 2. Example 4. The final example in this. If I am given 8 over root 6 to simplify, I'm asked to simplify 8 over root 6. What do I do? My solution. I have 8 all over root 6. To simplify this, because I have this irrational number root 6 in my denominator, I'll just use it to multiply both my numerator and denominator. So I'll be multiplying here by root 6. I'll be doing the same thing here, root 6. I told you the reason why you're doing this is just to eliminate this, but in essence you've not changed anything, because this over this can still cancel to remain your question given to you. So let's multiply numerator times numerator. 8 times root 6 will give me 8 root 6 all over root 6 times root 6. Because we did this, it will just be what? 6. I can't leave my answer like this because I can simplify further. 2 into 8 is what? 4 root 6. 2 into 6 is what? 3. So it is 4 over 3 root 6. That is the final answer. So we succeeded in simplifying this to give us 4 over 6 root 3. Now let's look at conjugate of a surd. The essence why we have a conjugate of a surd, if you remember your difference of two squares, let me draw your mind back to difference of two squares. Difference of two squares. Just recall, if you are given a squared minus b squared, it is the same thing as what? A minus b, open and close brackets, a plus b. Now, these two are conjugates of each other. What does conjugate now mean? If I'm given root a minus root b, and I'm asked to determine the conjugates. Determine the conjugate. The conjugate of a surd is just changing the sign that separates the two surds, that separates the two irrational numbers. This is root a minus root b. The conjugate will be root a plus root b. I'll show you the essence of doing this when we come back to the rationalization. But now we are now having a denominator that is not just a single irrational number, but we are having an equation there. Maybe it's root a plus root b, or a rational number minus an irrational number. So we'll take some examples to actually understand this. But just remember this equation, because when we come to applying it, you just have this. Because when I multiply this now, when I multiply this, that's root a minus root b, brackets, root a plus root b, because I'm multiplying conjugates. This is the formula, this is the rule. If this is my root a, root b, root a, root b, just the sign that is different, it will give me a squared minus b squared. So for this one, it will be root a squared minus root b squared. What have we succeeded in doing? This square, we cancel the square root. The square, we cancel the square root. The square will cancel the square root. So I'll be left with what? A minus b. So when I multiply two conjugates of a surd, I'll be having a rational number. So that's the essence why we are introducing conjugate of a surd. so that in our examples we now understand how to apply them. Conjugate. Simplify 3 all over with 3 plus with 2. Now let's do this. Let's see what we'll arrive at. Solution. Remember that because we are now having two terms in our denominator separated by a sign, we are going to apply our conjugates. Remember that. So my 3 all over root 3 plus root 2, what would I be doing? I will be multiplying by the conjugate of this. I told you the essence of multiplying by the conjugate. When I multiply this by its conjugate, it reduces to a rational number. Anything I do to my denominator, I'll do to my numerator. That's why I'll multiply also with 3 minus root 2. Anything I do here, I'll also do here with 3 minus root 2. Now, everything you have here can cancel out to give you 1. So I've actually not changed the question. All I need to do is just, because I want to eliminate my irrational number from the denominator, I'm multiplying both sides by the conjugate. Now all I have to do is this 3 multiplied by everything here will give me 3 open bracket of root 3 minus root 2. Then everything here multiplied by everything here. Remember our rule. Remember that rule I wrote. A squared minus b squared is equal to a minus b into a. Let me write it out properly so you see very well. I'll write it here. A squared minus b squared is equal to a minus b into a plus b. Just remember this, your difference of 2 squares. So it's the same thing here. So this multiplied by this, just check it to be this. It will give me root 3 squared minus root 2 squared. So this will give me what? You can decide not to open up this bracket because this 3 multiplies everything. So it's still 3 into bracket of root 3 minus root 2. You cannot subtract this because they are not similar. Remember when we did similar sorts? All over. If I square here, the square will cancel this square root. I'll be left with what? 3. Minus this square will cancel this square root. I'll be left with what? 2. So this will give me 3 into root 3 minus root 2. 3 minus 2 is 1. So everything over 1 is still the same thing. So that is our answer. Example 2 under conjugates. Simplify 2 plus root 3 all over 2 minus root 3. Alright, now you can see that in our denominator we have one irrational number, we have a rational number. But the same thing that applies when you are having 2 irrational numbers is the same thing we are going to also do here. Our conjugate of this denominator is just by changing the sign that's between your rational and your irrational number. So solution. I'm having 2 plus root 3 all over 2 minus root 3. So what do? I'll be multiplying by the conjugate of my denominator. I say the conjugate of the denominator is just to change the sign that is here. So I'll be having 2, the sign here is minus, I'll be changing it here to what? Plus 3 all over. Anything you do to the top, you do to the bottom. 2 plus 3. Now, everything here, the top and bottom is the same. It can cancel out to 1, you'll be back to this. But we don't want to cancel out. So I'll be multiplying this times this. So this will give me 2 plus root 3 to multiply 2 plus root 3 all over this times this. Remember that these two are conjugates of each other. Remember our difference of 2 squares. This times this will just give me 2 squared minus root 3 squared. Always have that at the back of your mind, that the simplification of this is difference of 2 squares, a squared minus b squared. if you open up this bracket, these two multiply everything here, this will multiply everything here. Remember it also. So let's multiply. 2 times 2 is 4, plus 2 times root 3 is 2 root 3. Then I'll use this to multiply everything here. Root 3 times 2 is 2 root 3. Root 3 times root 3 is what? Root 3 squared. I'm doing this so that you understand every process properly. 2 squared is what? 4 minus root 3 squared. The square will cancel the square root. I'll be having what? 3. Follow carefully. Alright, the next thing is what? Let's still work on this. 4 plus 2 root 3 plus 2 root 3 plus root 3 squared. This square will cancel the square root. It will be what? 3. 4 minus 3 is what? 1. Now remember your similar surds. I'm having a similar surd here. I'm having root 3. I'm having root 3. Remember when we treated similar surd, we say the similar surd is a surd that the irrational number is the same. This is an irrational number root 3. This is another irrational number root 3. They are the same. And in addition of similar surd, I'll just add my rational numbers. So this is 4. This 4 looks like this. So 4 plus 3 is what? 7. Plus 2 root 3 plus 2 root 3 is 4 root 3. This is your answer. Remember, I cannot add the irrational number with the rational number. That's why I only added this and this. And I added this and this because these two are similar surds. They both have root 3 inside their roots. So 2 plus 2 is 4. 4 root 3. 4 plus 3 is 7. That's how we arrived at that answer. Take example 3. Simplify 4 over root 5 plus root 3. Solution. I'm giving 4 all over root 5 plus root 3. All I need to do is to multiply by the conjugate of the denominator. And what will be the conjugate? Root 5 minus root 3. Anything I do to my numerator, I do to my denominator. Root 5 minus root 3. So I'll multiply this 4 by everything here. So this will give me 4 into brackets. Root 5 minus root 3. All over. I told you the easiest thing to do here, difference of two squares. Root 5 plus root 3 times root 5 minus root 3 is the same thing as root 5 squared minus root 3 squared. So that this square will cancel this square root, this square will cancel this square root. So I'll be having 4 into root 5 minus root 3 all over 5 minus 3. This will give me 4 into root 5 minus root 3 all over 5 minus 3 is what? 2. I can simplify because 2 can go into 4. So 2 into 4 is what? 2. So my answer will be 2 into root 5 minus root 3. I'm sure you understand that this bracket means these two must multiply everything. So some other person will want to write 2 times root 5 is 2 root 5 minus 2 times root 3 is 2 root 3. These two are the same thing. I only simplify this. I factorize. This is called factorization of this equation. So that is our example 3. We'll take one more example on this and we'll say goodbye to surds. Example 4 says simplify 4 over root 8 plus 3. Alright, now if you look at this, it's a bit different because I'm having one part as a fraction and the other part as a whole number. So the first thing is I'll make everything as a single fraction. My solution. Four over root 8 plus 3. This 3 is the same as 3 over 1. Let's do it as though we are in primary school. I'll take the LCM between this and this. The LCM is root 8. Root 8 into root 8 is 1. 1 times 4 is what? 4. Plus 1 into root 8 is root 8. Root 8 times 3 is 3 root 8. So now I've made everything into one single fraction. But remember that when we started, we said we don't want to see an irrational number in our denominator. And also this root 8, remember when we did simplification of surds, I can simplify my root 8 as a I can actually have 4 in root 8, which will give me the square root of 4 is 2. So I can simplify this root 8. I can have that as 4 times 3 roots. This root 8 is the same as 4 times 2 all over this root 8 is the same as 4 times 2. Remember when we did perfect square, 4 is a perfect square. So I'll be having here as 4, sorry, here is not times, so don't forget it is plus that is here. 4 plus, now this 3, square root of 4 is what? 2. So I'm having 3 times, the square root of 4 is 2. I'll be having root 2 left. You put this in bracket this way. All over, square root of 4 is what? 2. Root 2. So I've succeeded in simplifying this to be what? 4 plus 3 times 2 is what? 6. 6 root 2 all over 2 root 2. Now, I'm having an irrational number in my denominator. I need to convert it to a rational number. How do I convert my irrational number to a rational number? Remember our example 1. All I need to do is I will now multiply by what? The irrational number here. Don't forget this is different from conjugate because it's just a single number here. So I can multiply by root 2 all over root 2. The essence of multiplying by root 2 is once root 2 multiplies root 2, it becomes root 2 squared, so that the square will cancel the square root. So this will give me, this root 2 multiplies everything here. So I'll be having 4 plus 6 root 2, bracket of root 2, all over this 2 root 2 multiplied by this will give me 2 root 2 squared. You can see it. I didn't square this one because I didn't multiply here by 2 root 2. If I multiply by 2 root 2, it will be everything here squared, but I only use root 2. You can decide to use root 2. Some other person will decide to add this 2 also. Then you would have to square here, but I only use root 2. That's why I'm bracketing only the root 2. So that this square will cancel this square root. So I'll be having 4 times root 2 is what? 4 root 2 plus 6 root 2 times root 2 will be 6 root 2 squared. The square is only for the root 2. All over what? 2. This square has cancelled the square root. 2 times 2 is what? 4. So that I'll be having it as 4 root 2 plus this square, we cancel the square root. 6 times 2 is what? 12 all over 4. This 4 can go into here. This 4 can go into here. So I can reduce this equation. 4 into 4 root 2 I'll be left with root 2 plus 4 into 12 is 3. So we succeeded in reducing that question to what? 3 plus root 2. If you write it as root 2 plus 3, you are still correct. If you write it as 3 plus root 2, you are still correct. Any one you like, you write it. Alright, I'm sure we've succeeded in explaining to you how to do rationalization of surds. Now, if you have any question on the comment section, you just drop your question. I'll be very excited to reply to you. If you want it in video form, I can reply to you with another example. For my YX student, please endeavor to try your hands on past questions involving surds, because we've looked at everything relating to surds. I'm sure you'll be able to solve any question in surds. See you in my next video. I celebrate you.